Okay, fine. So, in the previous class, till the previous class, we have studied multi-level paging, and we also solved multiple questions based on multi-level paging, right? So now we are going to solve one or two questions based on that which has been asked in GATE exam, and we are going to solve this question that was asked this year, GATE CSE 2024 set 2, and it is a really good question that they asked, and you won't get solutions for this question proper solution of this question anywhere as of now. So I decided to solve this question in the class so that you can get to know how to approach this question. It is simple because we have already learned the concept of multi-level paging, and based on that concept only, it has asked the same type of question, but it is framed in such a way that students may get confused. Okay, so we are going to solve this question now, and after that we will be talking about this hashed page table and inverted page table. So this is what we are going to cover today, and we'll be solving few questions. I will be giving you few questions as a homework as well in today's class. So without waiting, let's start. So here, this is the question that we have from GATE CSE 2024 Sec 2. Let's read the question first. Consider a 32-bit system with 4 KB page size. So here page size is given, that is 4 KB, fine, or which is nothing but 2 raised to the power 12 bytes. And then it is saying page table entry size is 4 bytes. Page table entry sizes 4 bytes each. 1 KB is 2 raised to the power 10 bytes. We know already, right? The OS uses a 2-level page table for memory management, with the page table containing an outer page table directory. That means the outermost level is there, and an inner page table is there, inner level is there. So 2 level of paging is used. The OS allocates a page for the outer page directory upon process creation. Now this line is very important, because using this line we can clearly understand that for the outermost page table or page directory, OS allocating a page. That means that outermost page table is stored in a page. Is this point clear? It is stored in a single page, the outermost page table. Is this point clear? This is very important line. The OS uses demand paging when allocating memory for the inner page table. Demand paging means whenever you need particular page, you are going to load it. Okay, you are going to load it into the main memory. So this is what it is saying. We are going to discuss demand paging, what it is, in the upcoming lectures. But as of now, just understand that demand paging is whenever we need some page, we are going to have it in the main memory from the secondary memory. That is, a page of the inner page table is allocated if it contains at least one valid page table entry. So if it is a valid page table entry, it is going to be there in the main memory. That's what it is saying in brief. An active process in the system accesses 2000 unique pages during its execution. So a process is using 2000 unique pages. If you remember, in the previous class, we have solved this type of questions also, right? Where we know that process is using, some memory, right? Out of the entire virtual address space or logical address space, it is consuming some amount of memory, and through that we calculated the number of pages. Yes or no? We have covered these type of questions, yes. But in this question, it is directly given to us that these unique 2000 unique pages are used by this process in the system, and none of the pages are swapped out to disk. That means all these pages are present in the main memory. Simple, right? After it completes the page accesses, let X denote the minimum and Y denote the maximum number of pages across the 2 levels of the page table of the process. So X denotes the minimum and Y denotes the maximum number of pages across the 2 levels of page table, right? And we have to find the value of X plus Y. Is this question clear to you? Please let me know once, then we can proceed to see how we can solve this question. If you have any doubt, please ask. All clear, Abhas? So basically, when it is saying in the last line that maximum or minimum number of pages across the 2 levels, so basically it is talking about the chunks, the total chunks that we can have. And we have already solved these questions, right? Am I properly audible and visible to you, Abhas? Please confirm once. Is it fine? Okay, okay. So yeah, so let's solve this question now. Let me add one slide here. So page size is given, that is 4 KB. So 2 raised to the power 12 bytes. Page table entry size is also given, that is 4 bytes. Virtual address space is of 32 bits, correct? Yeah, 32-bit system. Okay, so 32-bit, fine. And two-level paging is used. So definitely this is going to be the split, right? Two levels of paging, and here we are going to have the offset. As we can see, 2 raised to the power 12 bytes is the page size. So what will be the page offset here? Page offset will be 12 bits. Yes or no? Page offset will be 12 bits, right? Now, what about the bits present here? How to know how many bits are present here at the outermost level and how many bits are present at the innermost level? So here, if you see this line, the OS allocates a page for the outer page table directory upon process creation. We know that the bits present here and here, 2 raised to the power that represents what? The number of entries, the chunk size at that level. Yes or no? That represents the chunk size at that level. So we know that the outermost page table, let me write, since outermost page table is stored or allocated in a page, in a single page, right? As it is given in the question. So we can say that the number of, we can say the outermost page table, can we say that chunk size at the outermost? What will be the chunk size at the outermost? I can say it is going to be 2 raised to the power 12 bytes. In terms of bytes, it is going to be this, because the entire outermost page table, we know that the entire, the outermost page table is nothing but one chunk. We know it, right? Because we are not further dividing it. So definitely it is going to be one chunk. So that chunk size will be equal to the page size. That chunk size will be equal to the page size. Page size is 2 raised to the power 12 bytes. So definitely the chunk size at the outermost level will be 2 raised to the power 12 bytes. But we want this in the number of entries. Yes or no? We want this in terms of entries. So we know that 2 raised to the power 12 bytes divided by the page table entry size, 2 raised to the power 2. That means in terms of entries, it is nothing but 2 raised to the power 10 entries. Is this point clear so far? Clear? So if the chunk size at the outermost level is 2 raised to the power 10 entries, can I say I need 10 bits here? Yes or no? Can I say I need 10 bits here? Is this point clear? Any doubt so far? So if 10 bits are there for the outermost page table, right? Outermost page table, if 10 bits are there, definitely 10 plus 12, that is 22, 32 minus 22. Again, this is also going to be 10. So can I say this is going to be my virtual address split? Yes or no? This is going to be my virtual address split. Is this clear, Avas? If you have any doubt, you can ask. Okay. So this is the scenario. This is the scenario, right? This is the virtual address split now. Now the question says that this active process in the system accessing 2000 unique pages during its execution. Okay. So let me add one more slide here. So here we have, let's say this, we have this virtual address space, or you can say logical address space, because so far we haven't talked about the virtual memory concept, right? So in this one, the process is utilizing, let's say it is utilizing 2000 pages, as it is given in the question, 2000 unique pages. So we have pages here, okay? multiple pages. So total 2000 unique pages are there. Now, if total 2000 unique pages are there, so what about the page table, the innermost page table? How many entries would be there? Can you tell me that? If 2000 unique pages are there in the virtual or logical address space, how many entries would be there in the innermost page table? Obviously, it is going to be 2000 entries, right? 2000 entries would be there because we know every entry is pointing to one page which is present in the main memory frame, correct? Every entry of this innermost page table is pointing to the physical memory frame that is storing that particular page. We know this concept, right? So if 2000 unique pages are there, 2000 entries would be there. Now what? Now here it is saying in the question that we have to find the minimum and the maximum number of chunks across the two levels of the page table, across the two levels of the page table. So first, let's talk about how we can find the minimum. How we can find the minimum? See, chunk size here is also 2 raised to power 10 entries. Yes or no? Because here 10 bits are there, right? 10 bits are there. So 2 raised to power 10 entries. And if I talk about the, this outermost page table, here also the chunk size is 2 raised to power 10 entries. Fine. So at both the levels, the chunk size is 2 raised to power 10 entries. Now, if I want to find the minimum chunks possible, how I can find the minimum chunks possible? Can I say minimum chunks possible would be when in less chunks, I will be having more entries. Can I say so? That means they are more compact, they are more contiguous, they are not spread over entire page table. Are you getting this point? Yes or no? So if 2000 entries are there and chunk size is 2 raised to power 10 entries, can you tell me minimum how many chunks would be present at this level, at this innermost level? Can I say if I have total 2 raised to power 2000 entries, if I divide it by the chunk size, which is 2 raised to power 10, that means nothing but 1024. How many chunks would be there? Yes. How many chunks would be there? It is going to be two. Two chunks would be there. Yes or no? Because if you have to take, if you divide 2000 by 1024, it is going to be 1 point something. But you have to store all the entries, right? So you have to take the seal of it. So you will be getting what? Two chunks. That means in two chunks, let's say one chunk is this and another chunk is this. So in two chunk, you are storing in all these 2000 entries together. So one chunk is here and one chunk is here. Is this clear? Now we know this at the outermost level, every entry point to one chunk of the next level. So this entry will point to the one chunk of this level. This entry will point to the one chunk at this level, right? And we are only worried about these two chunks because we are not worrying about any other chunk because we are just dealing with these 2000 entries, which is pointing to 2000 pages in the main memory frame, right? So how many chunks? We know that this is going to be one chunk, right? So one chunk we need here, 1 plus 1, 2 chunks we need here. So can I say that the value of x is nothing but 1 plus 1 plus 1, it is going to be 3. Minimum these many chunks are needed across the two levels. Is this clear? So here if you see the question also, here it is asking x denote the minimum number of pages across the two levels of the page table of the process. So when it says number of pages across the two levels, that means it is talking about the chunks, because as I explained you in the in the multi-level paging concept, that when we talk about the other except the inner level page table, when we talk about or except the virtual address space, when we talk about all the levels of page table, we deal in terms of chunks. Yes or no? We'll deal in terms of chunks and the entries. Correct? So here it is asking about the number of chunks that can be present, minimum number of chunks that can hold all these 2000 entries together. So we need 3 chunks here, 1 here, and 2 here. Is this clear so far? Yes, Abhas? Any doubt? All clear? Okay. You're looking today's little silent. Okay, fine. Right. So minimum 3 chunks are needed here. What about the maximum? How to find the maximum? See, if I want to find the maximum number of chunks, can I say at this level, that these 2000 entries will be spread all over the page table? Can I say so? Because if I want to find the maximum, definitely these 2000 entries will be spread all over the page table, right? If these 2000 entries can spread all over the page table, then how many chunks are possible? We know this, that if outermost page table chunk size is 2 raised to power 10 entries, and each entry can point to 1 chunk. Can I say 2 raised to the power 10 chunks are possible here? Maximum here. Can I say so? That maximum, let me add one more slide here. So this is your virtual address space. This is the page table, innermost page table, and this is the outermost page table. Now, I know this, that the chunk size here is 2 raised to the power 10 entries. And here also the chunk size is 2 raised to the power 10 entries, right? Now I have these 2000 pages, unique 2000 pages. 2000 entries would be there. I know this, that here at the outermost level, I have this is 1 chunk only, right? This is 1 chunk. This is 1 chunk. Now I know this, that the chunk size here is 2 raised to the power 10 entries. So I know this, that every entry is going to point to 1 chunk. Every entry is going to point to 1 chunk. Every entry is going to point to 1 chunk. So how many such chunks are possible? If 2 raised to the power 10 entries are there, so definitely maximum 2 raised to the power 10 chunks will be there. Yes or no? Yes or no? And if I have 2000 pages, that means 2000 entries are there. 2000 entries are there. Can I say every chunk is storing at least 1 entry? Because if I want maximum, that means I want to use all these chunks. If I want to have maximum number of chunks, I have to use all these chunks. That means these 2000 entries, at least 1 entry will be there in every chunk. And some chunks can have more than 1 also, because I have to accommodate all these 2000 entries in all the chunks. Yes or no? So I need a maximum chunk. So maximum chunks will be 2 raised to the power 10 here. And here we have 1 chunk already. So total Y value will be what? Maximum if I talk about. Y is denoting maximum. So maximum would be 1 here. So 1 plus 2 raised to the power 10. So this is 1024 plus 1, 1025 chunks would be the maximum value. And what we need to find? We need to find the value of X plus Y. So X is 3 here and Y is 1025. So X plus Y is nothing but 3 plus 1025, and that will give me 1028 as the answer. Is this point clear? Any doubt so far? So you can see that whatever concepts, all the concepts that we have covered, on the basis of that, you can solve the question easily because your foundation is strong. You know each and every concept, you can visualize everything clearly, right? So you will be able to solve every question. You just need some practice, you just need the revision, that's all. Because now the concept of multi-level paging is clear, right? Any doubt in this question? If you have any doubt, you can ask. Yes, Abhas, do you have any doubt? (1025) is not the answer. 1028 is the answer, because we have to find the value of x plus y. Here, x plus y. Here you can see the value of x is 3. The y value is 1025. So final answer is 1028. 1028 is the correct answer. This question was asked in this year, 2024. Clear? So if you observe carefully this question, what was the important, we can say the dots that you have to connect while solving the question. The first thing, when you are reading the question, you should focus on this line. I'm just telling you what are the important points here. Carefully see. The first thing you should focus here, that the outermost page table directory is allocated a single page. That means page size and the chunk size of the outermost is going to be same. This is the first thing. So you have to, when you are reading a question, you have to pick these lines. What else? Then it is saying 2000 unique pages are there. That means it is not using the entire virtual address space, just it is having 2000 unique pages in the system, right? So this is the second thing. Then it is saying that x minimum and y maximum, denoting the page number of pages across the two levels. That means whenever it is saying number of pages across the two levels, that means it is talking about the chunks. Because when we are talking about multi-level paging, we deal in terms of chunks, right? And the chunk size in terms of entries. This point should be clear in your head, right? Now, so first thing we have to know how many entries are there. So we have to find the virtual address split first. So this was the hint. Due to which we would be able to find what will be the split here. Because if this is not given, as I told you in the lectures also, that every time they are going to mention something in the question which will decide this virtual address split. Because if this line is not there, that outermost page table is stored in a single page, in that case you could take 12.8 also. That is also possible in that case, if this line is not given, that outermost page table is stored in a single page, right? So every time they are going to mention in the question that the outermost page table is stored in a single page, or they will mention something else by which you will be able to identify what is the split here. Okay, so we found out that the chunk size at the outermost level is going to be the same as the page size, because in a single page we are storing the outermost page table. So in terms of bytes we have calculated, but we want in terms of entries, because these bits, 2 raised to the power, these bits will give me the chunk size at that level in terms of entries. So I divided by the page table entry size and I got 2 raised to power 10 entries. If 2 raised to power 10 entries is there in the, the chunk size at the outermost level, definitely 10 bits would be there here. And if these are 10 bits, definitely if you perform the maths, you will be getting 10 bits here. So this is going to be the virtual address split. Then we know the concept that if 2000 unique pages are there, definitely 2000 entries will be there in the innermost page table, because we know every entry is going to point to one physical frame of the main memory, which is storing that particular page. So pages is going to be equal to the number of entries here, 2000 entries, right? And the chunk size here is 2 raised to power 10. So minimum if you have to find, so all has to be contiguous. If all has to be contiguous, then definitely 2000 total entries are there. Chunk size is 1024. So we have to find minimum chunks, right? So if you divide it, you will be getting 2. You have to take the seal, because you have to store all those 2000 entries. And you can store all those 2000 entries when you are using 2 chunks. In 1 chunk, you will be able to store just 1024, but we have to store all. So 2 chunks are required. So, and at the outermost, every entry is pointing to 1 chunk here. So, and we know the outermost is always going to be 1 chunk, because we are not further dividing into chunks. That is the concept, right? So 1 plus 1 plus 1 minimum is going to, we are getting as 3. What about the maximum? If I want the maximum, definitely I have to use all the chunks present in the innermost level. That means all these 2000 entries are spread over the entire page table. Yes. So if all the chunks I have to utilize, I know these 2 raised to power 10 entries are there, and every entry here is pointing to one chunk. That means 2 raised to power 10 chunks would be their maximum. If 2 raised to power 10 chunks are there, I can say that at least one entry is stored in one chunk. At least. You can have more than that. Definitely, you will be having more than that, because otherwise you will not be able to accommodate 2000 entries. But at least every chunk is storing at least one entry, right? So 2000 chunks here and one chunk here. So it will give you maximum 1025 chunks. And you have to find the value of x plus y. So that is nothing but 1028. Is this clear now? I hope now it is crystal clear, right? Shall we proceed now? So you will be able to solve. Now, if you have studied all these concepts, if you have practiced few questions, I can assure you that you will be able to solve any multi-level paging question.